Hello, and welcome to Virtual Investor Conferences. My name is Matt Lateplo, and on behalf of OTC Markets, as well as our co-hosts, Issuance and Going Public, we're very pleased you have joined us for our next live presentation from Monogram Orthopedics. Before I introduce our speaker, a few points to note. Please submit your questions in the question box at the bottom left of the slides. Once the Q&A session is ended, don't log out. You will automatically be transferred into the Monogram booth where you can continue to ask questions via chat and access additional offering materials. On a final note, all of today's presentations will be recorded and available for 24/7 replay. At this point, I am very pleased to welcome Ben Sexton, co-founder and chief executive officer, and Dr. Doug Eunice, co-founder and chief marketing officer of Monogram Orthopedics. Welcome, Ben and Doug.
Thank you so much. Welcome, everyone, and thank you for joining our presentation today. We're tremendously excited to share our story. So what is Monogram? Well, it turns out, and I know it's cliche to say, but we are revolutionizing the orthopedic market. And how are we going to do that? Well, we're going to start by taking a patient patient CT scan, and generating a digital model of our patient's bone. And then we're going to use that model to create a customized surgical robotic plan with an extremely accurate robot. And then we're going to 3D print with 3D printed high-strength medical-grade titanium alloy, a patient-matched, patient-customized implant. And the end result is going to be the implants of the future. So this animation here kind of gives you a sense of how the workflow all comes together. But the end result is implants that are smaller, more stable, better restoring the anatomy, and it's also a much more capital efficient model, as you'll soon see. So the biggest question we get is, can anyone do this? Well, to answer that question, we have to kind of do some anatomy 101 and explain that there's actually a lot of IP behind what we're doing, and it's not just 3D printing in the old shape. When you look at bone, a lot of us have a sense already that bone is not uniform and kind of understand, bone and bone marrow, for example. But it's important to know that bone is basically comprised of two layers, a dense outer layer that we call cortical bone and a soft inner layer that we call cancellous bone. And that hard cortical bone loves to grow into porous metal, like monograms, if the conditions are right. But because most knees aren't patient optimized, generic implants are usually cemented in. And that's not great, because if you think about a sidewalk that cracks, the same principle applies to cement and an implant, which is part of why we don't like to put implants into younger patients. So about 92% of knees are actually cemented today. We want to change that. We believe that natural biologic fixation is possible, i.e. that we can have bone grow into patients and really improve outcomes. But you just don't want to kind of print any old design. So let's look at generic implants for a second. Let's dive a tad bit deeper here. If you look at this implant on the left, this is what the typical generic implant looks like. It's flat with a central keel. Now, what Dr. Eunice, who's done hundreds of these procedures, started to notice is that the design just isn't inherently stable. It reminded him, in fact, of a seesaw. You have this central point of stability, and you have loading at the periphery, and it's just inherently unstable. Tibial components are, in some sense, designed to fail. So what Dr. Eunice said was, hey, we've got a CT scan, we've got robotics, we've got 3D printing. Why don't we redesign implants so that they interface with the best bone, the most biologically active bone? So we take a CT scan, and we're able to identify that bone. And we're able to design implants that abut that really biologically active, dense bone. And you can see here, as shown in red, that's that inner cortical wall. And because we have robotics and CT scans and 3D printing, we can really account for the patient variability. But the innovation doesn't just end with knees. In fact, when you look at hips have similar problems. With hips, a lot of the challenges actually relate to how we put these things in. We're basically hammering in the implants, and the video got separated here, but We kind of joke that they're like log splitters, and quite literally, if you've seen a hip procedure, it doesn't look that far from that. And you might be asking yourselves, well, hey, I know somebody, their knee went well, their hip went well. Are these failures really a problem? Well, it turns out that they are. The revision burden for knees is about 9.6% per year, and for hips is about 14.6% per year. And we get some objections showing investors this slide because they say the study is from 2015. But the reason we are kind of insistent that we look at this data is because this is not a cherry-picked sample of 100 patients that some joint company is telling you the procedure is perfect. You can see the data set here. We're talking about looking at, well over 1 million patients. And we think that when you look at kind of large sample data, it's obvious that this is not a perfect procedure. So why can't anybody do this? Well, first of all, we've protected these ideas extensively. So today we have 8 patents filed with more expected. And anybody can maybe 3D print or use a robot, but it's how we combine things that makes Monogram really special. And we've showed why this matters on this slide. So on our knee, we tested our designs against one of the leading press-fit generic equivalents, the Stryker Triathlon, which is one of the most clinically and commercially successful press-fit knees of all time, and represents about 36% of Stryker's knee business. And we showed with the University of Nebraska that in some modalities, the Stryker implant had 270% more micromotion. So we really were able to demonstrate that our implant is incredibly stable against leading implants on the market. And the same for our hip. In a collaborative study with UCLA, we demonstrated that a leading Zimmer stem had up to 630% more micromotion, and then we had up to 900% more cortical contact with that dense biologically active bone. And as you can see in the bottom left image, we were able to preserve considerably more bone. So you might be thinking, okay, well, what is our competition doing today? Is this really that different and really that novel? Is our competition thinking about the fact that people are different? Or are they looking at the market as more kind of cookie cutter sort of shapes? Well, it turns out that most implants today just basically look very similar, flat with a central keel. And it's the same for hips. And the reason for that really ties into how the procedure is done. We're relying on technology that's been around for a long time. And as you can see here, the way that we actually execute procedures is by affixing jigs that constrain planar saws, and we really only have the ability to make flat cuts. And because we're constrained by the instrumentation we have, the implants, therefore, really kind of match what instrumentation we have to put them in. So we're really, where we are today is constrained by sort of technology that hasn't moved forward. And the other problem with this is that it's incredibly inefficient. It's a very, very costly business model. In one case study we ran, we showed that for just $4.7 thousand of revenue, there was $75,000 of implant inventory and $23,000 of instrumentation in the case. Just a really inefficient market that needs a better solution. So we've shown that implants today are basically me too, but what about on the robot side? Aren't a lot of people doing this? This seems like an obvious opportunity. And the fact is that amazingly, no. Stryker has almost 87% of the orthopedic robotic market, with a few other players sort of in the game, but really struggling. And we think that the market has clearly spoken, and basically there's only one relevant player in the orthopedic robotic market, and that's Stryker. One question we get, and I just want to kind of cut it off at the pass, is, isn't Intuitive Surgical doing this? Well, Intuitive Surgical, I just want to iterate, is not a competitor in the orthopedic market. They have endoscopic instruments, and it's not an orthopedic robot designed to efficiently mill bone. They have a completely different indicated use. The market is really Stryker and then a few other players. And I'm just going to kind of go through these really quickly, but just show you, okay, this is where the market is today. So what we're showing you represents basically 100% of the orthopedic robotic market. You can just kind of see as we go through the different players, nobody seems to have anything that is very compelling, and Dr. Yunus in the Q&A can address any specific technology that you'd like. But we understand and have looked at all of these technologies. Dr. Yunus has used or seen demos or been really involved with all of these technologies. And there's really no robot on the market today, with the exception of Stryker, that we think has really the potential to usher in what we think is the future of orthopedics. It's worth mentioning also that Conformis is sometimes comes up as a comp that people ask about. We'll just say that Conformis is using cemented implants, and they're using patient-matched jigs. They don't have a robotic system, and we think that they're the reasons for failure we can get into, but we do not see Conformis as a comp to what Monogram is doing. What we're doing is 3D printing patient-optimized press-fit implants, and we think that's the future of orthopedics. So let's look at Stryker and why they're winning. Well, it turns out that Stryker has a couple of things that they're doing that are very, very specific to them and unique. And the biggest thing that they're doing that's unique is they're using CT-based planning. And they're the only robot on the market that is using a patient-specific planning approach. And it used to be that this was objected to because of the cost of a CT scan, but Stryker has been able to demonstrate that the incremental $209 that the patient or the payer has to pay is well worth it when you look at the outcomes. You have improved accuracy, you have real-time accurate visualization. There's just a lot of benefits to using a CT planning approach, and it's really causing them to win and dominate. And Monogram recognizes this, and we plan on being the second robot arm on the market that uses a CT-based planning approach. But we're going to do a couple of things that Stryker isn't doing that we think are going to take robotics to the next level. Specifically, Stryker is a user-initiated cutting robot. So the surgeon grabs onto the end effector and moves the robot around in a constrained environment. Monogram is going to be an active robot. So our robot is actually going to execute with kind of pre-optimized cut paths the cuts on its own with incredible efficiency. There's a lot of other technical benefits that we're going to get into. Like, for example, our arm has 7 joints, the Stryker arm has 4 joints, but really what it boils down to is we're taking robotics to the next level, where we're really going to start untapping the full potential of customization. So here you can see some video of our robot. It's as I said, a 7-joint arm. It has can carry a 33-pound payload. It's got incredible position accuracy. It's just an incredible arm. And we're going to combine this arm with our 3D printed implants and really create something very, very special. And there's a lot of enhancements we're making to the robot to make it surgeon-friendly, user-friendly, and we're developing with our surgeon panel to make sure that everything we're doing is relevant to what they're looking for. And here's just another view of a robotic system. It's a cart-mounted robot, cart-mounted navigation carts, multiple monitors for the guidance application, real-time visualization. So let's just jump real quick into the opportunity. The future of orthopedics is robotics. This is undisputed. By 2027, there's studies that suggest that over 500,000 knees will be robotic, and over 100,000 hips will be robotic. This is the biggest growth opportunity, in our opinion, in orthopedics. And not only is robotics the biggest growth opportunity, but we see for knees specifically that the transition from cemented implants to uncemented implants is going to be a massive growth opportunity. So as I alluded to earlier, only 8% of knees today are uncemented. We think that that's going to go much, much higher. When you look at hips, 95% of hips today are uncemented. And from a period of 1999 to 2019, went from 40% to 95% in that period. So we see tremendous growth opportunity. We've seen studies that show that the cementless knee market is going to grow by over $1 billion in the next 4 years. And it's because of the reasons we talked about. Cement just isn't as good as uncemented. And what's beautiful is the combination of robotics and innovative implant design, we think that Monogram's bringing to the table will really give us a unique position for that opportunity. So as you kind of look at where the market is today, nobody is really combining robotics with patient optimization and 3D printing for press fit knees. So we think what Monogram is developing is going to be extremely compelling. And what we're developing is basically a press fit total knee that is more stable than the competition, but bone sparing, easier to revise, just all around, in our opinion, going to be a superior implant that we're going to combine with what we think will be the best CT-based robotic arm on the market. And how are we going to do it? Well, we have a really solid team. We have now 18 full-time employees. We have just finished pretty recently a cadaver lab that we put in. It's a 300 square foot cadaver lab. We have dedicated robotics in the lab, dedicated navigation systems. We have autoclaves. Our facility is, we have two facilities. One is 4,000 square feet and the other one's almost 2,000 square feet. So we have a lot of room to grow into. We're based in a really convenient location for surgeons and folks to come in and see and run demos. In terms of our roadmap, everything's really on track. This is what we've kind of publicly shown. You can see all this data on our Start Engine page, startengine.com/monogram. But we're on track for a early 2023 robot submission. We expect to commercialize our implants before that. And just going to run through kind of quickly what our implant roadmap is. So Monogram has all of the compelling data that we showed you really was for the tibial component, which is that bottom implant component. So we've licensed a femur insert locking mechanism and patella that we are going to be combining with our novel implant system. And on the top right there, you can kind of get a sense. So we're starting out by converting the implant that we've licensed into a really, really compelling press fit knee. We're going to do that with a special 510K that will be a very quick approval, we expect. And we're going to take that upgraded knee, that upgraded femur insert patella and locking mechanism, and we're going to combine it with our novel tibial component. And we've also, we're about to announce some licensing agreements, additional licensing agreements. We have licensed a partial knee and a total hip. So now Monogram is in a position where we have really a comprehensive portfolio. We have a total hip, we have a partial knee, and we're about to have a partial knee. We're about to have a total hip as well. So really the full bag for large joint replacements. And the plan is to incorporate all of these onto our robotic platform as quickly as we can. So we expect to generate revenue this quarter, and that's through the licensing agreements that we have in place. So really our plan is to take the implants that we've licensed, and through the leverage of our very attractive product pipeline and cadaver lab, bring in surgeons and upsell them on the future of Monogram. But this also allows us to build out our distribution, build out our ERP system, scale the business, start to generate cash flow. So it's really very exciting. We've had implants that have been shipping the past couple of weeks, and we're really excited to start to have that infrastructure and grow to becoming a real company very quickly. Just want to really highlight as we get into the close here, I want to give plenty of time for questions. Monogram is going after a huge market. It's an $18 billion market for just large joints, hips and knees. We also see applications in spine and other areas of orthopedics as well. We're starting with hips and knees as we kind of walk through. We have a really solid product portfolio for that, and we expect to scale from there. But you know, it's very rare, we think, to find startups that have a compelling business model for a large and growing market that is protected with extensive patent filings and so on. So we really think Monogram represents a unique opportunity for investors. We've raised to date, you can kind of see here our fundraising track record. We're fundraising through a portal called Start Engine. So startengine.com/monogram. When I checked earlier today, we had raised about $3.3 million on that platform. So we're almost at about $20 million raised, and really doing everything we can to accelerate our traction and grow. With that, I'd love to open it up for questions. And Dr. Yunus, are you on? Let's see here. So I'm gonna look at some of these questions here. So this one is from Trevor Weaver. He says, I saw an article from a few years ago. Oh, looks like I saw an article from a few years ago where a man received the first 3D printed tibia replacement. I'm not aware of any follow-up article about the efficacy, but I was wondering, is that a direction you're looking into going? So thanks for your question, Trevor.
I could take
Are you there,
too.
Doug?
Yeah, I'm here.
Okay, good.
Yeah. So that's that article that you're talking about is referring to replacing the kind of the middle part of the bone for a tumor, which is different than what we're doing. Those types of custom implants for like large tumor surgery, where big chunks, like big sections of the bone, might have to be removed to get rid of a tumor. Custom kind of pieces of metal that fill in that middle part of the bone have been around for a long time, and 3D printing is kind of a newer way to make those things more efficiently. But those are one-off kind of unique cases. What we're talking about is having essentially mass customization of joint replacements. So not for just unusual or kind of really unique situations, but in everybody that needs a joint replacement, providing a patient-optimized implant. So I guess that's the answer to the question, is that there's a difference between kind of using a custom implant for a weird one-off case versus giving everybody who needs a joint replacement an optimized implant.
Yeah, we should also add real quick that the Stryker Triathlon tibial component is 3D printed. It's just not patient optimized. So,
and there are others like that. There are some hip sockets that are commercially available that are now 3D printed, and in fact, 3D printing is going to become the way that most of these implants are made in the future. It's just more economical. It's easier to come out with new implants, and the companies are all investing a lot of money in 3D printing facilities.
Exactly.
That is the future.
Yeah. So really, we really want to stress in the presentation, it's not just about 3D printing, it's what you 3D print and how you combine robotics, CT planning, and 3D printing into a novel design that actually makes a clinical difference. So
exactly. And
the fact that other people are 3D printing is good for us. Yeah.
Exactly. And without a robot that can do the type of milling that Ben described, you can 3D print custom implants all day, but if you don't have a tool that can prepare the bone to create a custom cavity, you can't put it in. So it's about putting the whole jigsaw puzzle together.
So Chip Russo is asking, will the insurance industry support your approach? Do you want to take that, Doug, or do you want me to take that?
I want you to get started, and I'll chime in.
Sure. So, what's really important to understand is that, every procedure has basically a code that the surgeon would bill against, and so what we're doing with joint replacements is really a very standard procedure. So what it comes down to is just getting an FDA approval for the procedure. It's not actually that challenging.
Just to chime Oh, sorry, but yeah, I mean,
Go for it.
one of the big challenges that medical technology companies have sometimes is that they're creating technologies that don't have a code yet, and so you've got to
Yeah,
have a code be recognized by Medicare, et cetera.
exactly.
As Ben said, these are
Exactly.
a hip is a 27130 and knees a 27447, period. And that's what
Exactly.
we are. We
So,
fall within those codes. The codes are already there. There's no upcharge. It's just a different way to do the
exactly.
same procedure.
Probably worth mentioning, you might see some, Conformis has some interesting things that are happening in the news where because there's a premium for their implants and there are some incremental costs that come with it. For example, if you're 3D printing patient-specific jigs, that's something that's very difficult to optimize, right? That's an incremental cost that somebody has to eat, either the company or whoever's paying. So there has been some pushback uh, related to their ability to demonstrate a clinical benefit for the incremental cost. So insurance companies do kind of push back against that. But because what we're doing is so efficient and the robot isn't part of that transaction, the robot is a capital purchase that the hospital makes, there really isn't, insurance companies actually love robotics because, as Stryker has shown, it's cheaper to do a procedure with a Stryker robot than manually. They actually save money. So we think that technologies that normalize patient outcomes will be looked on favorably going forward.
Hey, Ben, there are two
Well,
questions that I think we should
sure.
probably address. One is asking about is a Reg A option still open to accredited investors? So we should probably clarify what is available right now. And then somebody else asked, what are our exit strategies, acquisition versus IPO?
Sure. Let's start with our exit strategy. So within the investor eligibility, we just invite you to go into startengine.com/monogram, and StartEngine does a really good job explaining who can invest and what the criteria are, and give you all of those details. And they're very, very user friendly. They're one of the leading sites on the market, and we also have 2 million shares that we've set aside that all we need is board approval to issue to a strategic investor, or if we wanted to make deal with, let's say, a very large VC, we have the capacity to do that outside of this round. But we just want to make folks aware of that. In terms of our plan, we think what we're doing is going to be a really big deal and massively accretive if we're able to get to market with our robotic solution and our implants. We think the market is lagging outside of Stryker. They're the only ones using a CT-based robot arm. And we think what the other companies in the space are doing will be technology misses. So, we really, everything we're thinking about is really from a shareholder perspective and trying to make sure that we are doing whatever we think is going to be the most accretive thing for our shareholders, whether an acquisition or an IPO. What's unique about Monogram is we have a compelling business model that can stand on its own 2 feet. And if we fund it and grow, we think that we will be in a position to compete. We also think we're a very attractive acquisition. So we're really evaluating everything from the lens of what is the best thing for our shareholders long term. And we've, Monogram and the board are constantly thinking about that. Doug, anything you would add?
No, I think I guess what I would say is that getting back to Stryker's dominance, and they're kind of eating up market share of the other companies. There is a certain amount of panic that's setting in with all the rest of the companies to kind of have an answer for them. And for that reason, Ben and I have been receiving a lot of interest from the strategics, the competitors to the Stryker. Yeah. They're very interested in what we're doing, and we have really high level talks ongoing with these companies.
Mm-hmm.
We can't really get into the details, but there's
Yeah.
the prospect for us getting acquired is good.
I would add to that, Doug, is that, the fact that we're crowdfunding is really an advantage that makes Monogram a little unique, because if, for example, we were able to make announcements that could be, let's say, exciting, there's the capacity from the crowd to raise the capital without necessarily a strategic having to take undue kind of allocate capital, early, let's say. One of the things people don't realize is that the strategics, a lot of the people at the companies are not incentivized to take risk. Crowdfunding is an amazing way for people who love what we're doing to get involved without having to take significant risk kind of before we've commercialized. So we're certainly looking at using crowdfunding to our advantage in that way, but certainly everything we're doing is thinking about what is in the best interest of our shareholders at the end of the day.
Yeah. One more question. I'm going to try to answer this. I don't know if we have a hard cutoff at noon, but if not, Steve Baker's asking about seeing a story regarding personalized implants from a company called Rejoint, which is an Italian company.
Mm-hmm.
So yeah, so Rejoint is doing something very, very similar to what Conformis has done. The problem again is that they're customizing parts of the implant that don't need to be customized, i.e., are unlikely to translate into favorable clinical data. And two, they're not designed to be press fit. You're still putting in the same cemented implants, which are not great for younger patients. And then the other thing is there's no robot. Because they do not have a really sophisticated robot that can mill organic shapes to any specification, they're limited in the same way that off-the-shelf implants are limited. They can only put in implants that can be put in with a saw. And so, at the end of the day, it's just going to be another version of Conformis. So I guess that's my answer to Rejoint.
Mm-hmm. And Jackie, is this a hard cutoff, or can we keep going? Yes, I guess, Doug, we can keep going and.
Please wrap it up. Okay. I guess we're
okay. Done. Sorry about that. Okay. SPACs, Kevin. Yeah, that's definitely something interesting to us. There was a rather large SPAC that was funded by a group that Doug knows, based out of New York City. Well, we'd love to answer more questions. Actually, Monogram is going to be putting on another webinar, and we're really going to focus on the Q&A. The date is looking like March 9th. We'll make an announcement on that. Please go to startengine.com/monogram. We share a lot of information there. Or if you go to our website, thebonebot.com or monogramorthopedics.com, register your email and you'll be kept up to date on everything we're doing. We really appreciate your time.